Hello and welcome to yet another podcast from YoungWonks. This one is continuing with our ongoing series of basic electronics, and we're going to discuss how transistors work in circuits. Now, as we always do, our objective is for us to learn the very basics of transistors and look at this as a starting point by which you could further understand the concept of transistors. Now, as usual, in case you have any questions as you watch this podcast, feel free to put it at youngwonks.com/podcast, and I have my eye on there and I could address any of the questions that come up during this podcast. Now, transistors. So transistors as such are three terminal devices, and as you can see, each of them have three legs, and they can be used for many purposes, but primarily they're used for switching and amplifying, and there are many other uses as well. But these are the devices that have really revolutionized the electronics the way we know it today. The reason why we have a complex smartphone with the computing power of almost a laptop or even a supercomputer of yesteryears on our palm is because of this particular device. The transistor allowed us to make very complex things happen on semiconductors. So it's made up of silicon and sometimes using gallium arsenide, but mainly silicon, which is a semiconductor, and this is commonly found in sand. And these are very, very small. Nowadays, you can find them up to the size of nanometers. Around 7 to 10 nanometers are the smallest ones. And this tells you that almost in a phone, you'll find millions and billions of transistors within that chip. Now, to understand this a little more, let's look at what is the past of the transistor. So the transistor was originally developed by William Shockley, John Bardeen, and Walter Brattain at Bell Labs in the December of 1947. Now, the transistor of those days was very different, but that was the starting point at which this was made possible, right? And over the last few years or decades, the transistor has gotten smaller and smaller and smaller, and now we've crammed in millions and even billions of them on our electronic devices. Now, broadly speaking, there are two kinds of transistors that we come across, right? One is a BJT, the bipolar junction transistor, and these were something that were originally invented, and they continue to be in use because they're not as small, but they do support larger currents and also quicker switching times. So they are still used in modern circuits. And the way they work, right? And you can see that the diagram shows you NPN or PNP. It is essentially like two diodes stacked back to back. So what is this NPN and PNP? NPN and PNP are semiconductor material. Now, semiconductors are things whose conductivity changes when you apply electricity to it or a voltage to it. Now, what happens is we have these semiconductor materials, and the N-type semiconductor materials are semiconductor materials where a larger amount of electrons are inserted into it. So that has more electrons which it can donate. The p-type semiconductor materials are something where there's a shortage of electrons and they're waiting to accept electrons. Now, in normal circumstances, nothing really happens. But when you apply a voltage across these materials, something starts happening. The electrons that are there get additional nudge to start moving in. And what happens is a channel is created through which these electrons can move. And as you can notice on the symbols to the end, there are three terminals. One is called the collector, as you can notice in this diagram. One is called the base, and one is called the emitter. So, and the arrows in the symbol indicate the direction of flow of current. So when a current is applied to the base, it creates a channel through which current can flow from the collector to the emitter. Right? Now, in the same way, the PNP as well. Now, there is a lot more to know about these transistors, but our focus is just on the basics. So what we want to know is that there are semiconductor devices. The N-type semiconductors have more electrons, and the P-type semiconductors are waiting to receive electrons. And when you stack them up and apply voltages, it creates a channel through which these electrons can flow. And this becomes something that gives us functionality that allows us to implement many, many complex electronic designs. Now, the second type of semiconductor transistors that we can see are called metal oxide semiconductor field effect transistors. They are MOSFETs and sometimes just referred to in short as FETs or field effect transistors. They also work on similar principles, but the way that they are designed, and you can see that over here, is that there is a base semiconductor material, and in that there are two sections that are put in which are of the opposite type of semiconductor material. Then there are terminals are called the source, the gate, and the drain. So they're very similar to the collector, base, and emitter. Whenever a current is applied to the gate, this affects the semiconductor materials, and a small channel is created from from the source to the drain, and through that the electrons can flow. Now, one thing to keep in mind is that the transistors behave differently at different voltages being applied. At a small voltage, it is as good as an open circuit. There is a section of the voltage for which it will behave linearly. Linearly meaning you increase the voltage, the current increases as well. And there is a part where it becomes saturated, where you increase the voltage further and there will be no change or very minimal change. So that is also something that would be of interest, but that's something that we can look at a later stage. So what we see over here are the MOSFETs with the N and P material and a metal oxide gate. So when electricity is applied to the gate, a channel is created and there can be current flowing through it. And you can see the symbol as well. It's a little more sophisticated for the FET. And this is what you will see that being used in our modern electronics a lot. So this is the FET is what allows us to use electronics the way we do today. Now, there are many uses for transistors, but we will focus on two basic things. One is a switch and one is an amplifier. And The switch is very important because a very low amount of voltage and current applied to the base or the gate allows larger current to flow through from the source to the drain. That makes it very useful because that allows us, whenever we write programs, let's say on a Raspberry Pi and stuff, for it to actually turn on an LED. This is kind of what's happening, is because we're writing code which turns on transistors, but it allows it to actually work with higher current and higher voltage GPIOs. Now, the first circuit we're going to look at is using the transistor as a switch. Here you have a battery pack connected and a LED circuit connected. In line, we have the MOSFET connected, or the NMOS in this case, but we could do the same thing with the PMOS as well with slightly different connections. And the voltage, a programmable voltage, has been applied to the gate. Now, we'll take a look at this circuit and see what it lets us do. Now, if you notice in this circuit, I can control the voltage being applied to the gate. What you can notice is as soon as I start increasing it, there is initially a small value where it doesn't respond as quickly. Now I keep increasing it, and now there's going to be a section where as I increase, it increases much faster. But then there is going to be a point at which the rate of increase slows down and is not increasing as fast as the increase in the voltage. This is very noticeable because now I'm at 20 volts and you can only see 11.8 milliamperes. So these were the three sections in the behavior of the transistor which were important to know. This is called the cutoff region, where the change in voltage does not affect the output. Then this is called the linear region, where you increase and you can also see the current increase on the output. And then there is called the saturation, where any increase does not significantly affect the output. So this is a NMOS as a switch. And you can also notice the properties of a semiconductor over here, where the resistance can be controlled by the application of electricity. Unlike a switch where you can either be on or off, you can actually apply a certain voltage to control how much current is flowing through. So this is kind of like a tap, if you understand in the terms of water. The tap is not only on or off. You can actually open the tap to a certain extent to control how much water flows through. And this is the functionality that the transistor provides us as a switch in this particular condition. Now, coming back to the second application that we had talked about was the transistor as an amplifier. Now, it amplifies signals that are applied to it, and the circuit here is a little more complex, so we don't really need to get into the circuit. What is the focus of this podcast is for you to understand that a transistor can be used as an amplifier. And what is an amplifier? What you can see, and let's look at this circuit in a little more closely, is that there is a power source of 9 volts, and then there is a signal, a sinusoidal signal that is being applied to the gate. What you can see is on the output, there is a gain. You can see here that this is in the 4 volts region, whereas the output is in the 20 volts region. It's not only that the waveform is big, even the scale is different. So it's almost a gain of 5 to 8 times. So the output is 5 to 8 times larger than the input. So this is very important, because if we are able to use a small signal and amplify it, this is the reason why things like guitar amplifiers and speakers are all able to work. And one of the most important ones is a hearing aid. A hearing aid essentially has a transistor amplifier that amplifies the audio signals coming into it. And so you can notice how they play such a crucial role in our lives. The circuit involves some resistors and capacitors, but we don't need to get into that right now. What we really want to know at this point is that a transistor can be used for amplifying voltage or current or both. Now, there are different ways in which a transistor can be connected to get different results, and that is one of the things that I would like everyone who found this interesting to really look at next. Three things to look at. What are transistor characteristics? So this transistor characteristics will show you a graphical representation of what happens to the voltages and the currents on a transistor when they are in operation. The second is another very important application would be that of an oscillator. Oscillator allows you to create sinusoidal signals as outputs. And the third thing to take a look would be the different modes, operating modes. These are things like common emitter, common base, common collector, common gate, source, drain, and all that stuff is also important to know, and would be one of the next steps for anybody who found this to be interesting, and maybe we could cover that at a later stage. So that brings us to the end of our podcast about the basics of transistors. I hope everybody who listened to it was able to actually take something from it and benefit from it. Thank you for watching, and stay tuned to YoungWonks Podcast. We do one every week on the basics at Saturday 6 p.m. So stay tuned for one next week. If you have any questions, do feel free to put it on at youngwonks.com/podcast. And that's me, Suchin, signing off. Until next week. Thank you. Bye.